What's up, guys? We're going to continue here with Chapter 7, Section 4. Now we're going to be talking about division. We just finished up multiplication, so now it's on to division, dividing powers with the same base. You want to make sure that you pause and copy out this entire slide. So to words, it says to divide powers with the same base, you're going to subtract the exponents, which makes sense. Because if you're multiplying powers with the same base, you added the exponents. So to divide them, we're going to subtract them. So this is the way this looks. If I have a over m, a to the m over a to the n, I subtract those exponents. A can equal 0, and m and n are rational numbers. Here's a couple examples of how this works. 2 to the 6 minus or over 2 squared is going to be the same thing as 2 to the 6 minus 2. And if I'm looking at this example right here, this makes sense because if I have 2 squared over under 2 to the 6, this is the same thing as 2 times 2 times 2 times 2. A lot of 2's here. And right here I have 2 times 2. And so if you guys remember anything, these 2's are going to simplify out and they become 1's, a bunch of little 1's, but they don't count for anything. It's just multiplying by 1. So if I write this out, what I end up getting is 2 times 2 times 2 times 2 times 1, which doesn't change anything. But I have how many 2's on the top? I have 2 as a factor 4 times. And on the bottom I don't have any 2's, so it's just 1. Which is equal to the 4th. This is the shortcut part of it. This is why it works, and this is just how you get to it very, very quickly. Here, if I use a negative, 4 minus 7 is negative 3. You can't leave a negative exponent, so you got to go ahead and switch that over here. So let's jump in here. But first, here is a very, very helpful public service announcement. Let's eat Grandpa. Let's eat Grandpa. Commas. They save lives. If you don't get that, you need to talk to your English teacher. All right, so dividing algebraic expression says what is the simplified form of each expression. So this first one, this is equal to x to the 5 halves minus 2, which is equal to x to the 1 half. That's it. All I'm doing is subtracting. So that should be very, very simple for you. On this one, I'm going to divide or separate these things out. So I'm going to have the m squared minus 5 for these two. And then I'm going to have the n to the 4 minus 3 for those two. And what that leaves me with here is m to the negative 3. And just n to the first, but I can't leave that negative exponent. The n is positive, so it stays where it is, but this must move down to the denominator, and then it becomes positive. All right, so make sure you have these examples copied down. You just subtract the exponents of the ones that have the same base. If you end up with a negative exponent, then you move that particular variable to the denominator of the fraction, like we did here. So here's a couple for you to try. The answers will be up in 3, 2, 1. All right, so here are the answers. I got x to a half and then n to the 5th over m to the 8th. If you did not get those, you need to check your work. So, all right, dividing numbers in scientific notation. Numbers. Population density describes the number of people per unit area. During 1 year, the population of Angola was 1.21 times 10 to the 7th people. The area of Angola is 4.81 times 10 to the 5th miles squared. What was the population density of people that year? So I'm going to take the number of people, and I want to know per square mile. So I'm going to take the number of people and then divide that by the square miles. Now I'm going to split this thing up into two separate things. So I'm going to have 1 and 21/100ths divided by 4 and 81/100ths times 10 to the 7th over 10 to the 5th. Now we've looked at earlier in the year, if I multiply fractions, I multiply straight across. I could undo that by creating two separate fractions, which is what I did here. So now I go ahead and I divide those two things. Just needs to be squiggly because it's an approximation. This equals about 0 0.252 times, and then this is just going to be times 10 to the 7 minus 5 is squared. Now this is not written in scientific notation, so I need to go ahead and change that so that it's 2.52 times 10 to the negative 1, because it's a small number, times 10 squared. And here I just add my exponents. So I get 2.52 times 10 to the first, which is such a small number. Let's just go ahead and multiply that by 10 and get about 25.2 people per square mile. All right, so when you are doing scientific notation, you just split them apart just like that. Let's keep moving. All right, raising a quotient to a power. You need to pause and copy this down. So to raise a quotient to a power, raise the numerator and the denominator to the power and then simplify. Just like when we were raising multiplication to a power, everything in the multiplication, or what's called a monomial, got raised to that power. If I have a quotient, everything gets raised to that. So a over b to the n is the same thing as a over n, a to the n over b over n. And this is how it looks for these particular problems. All right, so make sure you have that copied down. Let's see what it looks like in actual math. So it says simplify. So this is going to be z to the 2/3 times 3 over 5 to the 3rd. So both of these things go to the 3rd. 2/3 times 3 is just 2, so I'm left with z squared. 5 cubed is 125. So that's all I'm doing on that, is just, it's not distributive property, but it's kind of the same idea where I'm distributing this to both here and to here. So that's what you're going to do here. You get z squared over 125. Here's one for you to try. Go ahead and pause. The answer will be up in 3, 2, 1. All right, so here's what I got. 1 over a to the 17th. Follow this line of reasoning to get that. If you don't understand, don't leave negative exponents. The book example leaves that as a negative. I don't like that. Change it to a positive. All right, so simplifying an exponential expression. It says, what is the simplified form of this? If you have this to a negative 3, anytime you have this to a negative, then what you do is you flip this around and make that positive. And here's why. If I go through and make this whole thing negative, then that flips it and makes it positive. So in other words, I want you to rewrite this, flipping the fraction. So I'm going to have y to the 4th over 2x to the 6th. And now that whole thing is cubed. The negative flips it. All right, so that's the way you need to approach that, is that negative is going to flip the fraction. And now I go through and distribute this to everything. So I have y to the 4 times 3 over, be careful, this 3 gets distributed to everything down here. So it's 2 cubed times x to the 6 times 3. Oops, that's a 3. All right, so this cube right here goes to both the 2 and the x. So be very, very careful with that. That'd be an easy mistake to make. And then from here I get y to the 12th over 8. And then 6 times 3 is 18. There's nothing else to simplify. So that's it right there. Y to the 12th over 8x to the 18. Here's one for you to try. Go ahead and pause. The answer will be up in 3, 2, 1. All right, so that's what I got. 25b squared over a squared. Check your work against mine. Again, I flip the fraction, make that positive, and then this goes to everything in there. So be very, very careful with that. And that's it for today. So hopefully you took good notes, and I'll see you in class.